Hello everyone, my name is Paulo at Geusau and I obtained a bachelor's degree in computer science from the Vrije Universiteit of Amsterdam. My co-author is Bloem and today I'm very excited to present our paper called Evaluating the Robustness of Question Answering Models to Paraphrase Questions. So let's start with the problem. Question answering is a challenging research topic and QA models used in real-world applications are far from perfect and still make many mistakes. For example, small variations in semantically similar questions may confuse the QA models and result in giving different answers. QA models need to understand the meaning behind the words and the relationships, and those words can be ambiguous, implicit, and highly contextual. So, the motivation for writing this paper springs from the observation that QA models can provide a wrong answer to a question that is phrased slightly different compared to a previous question, despite the questions being semantically similar. And this sensitivity to question paraphrases needs to be improved to provide more robust QA models. And modern QA models need to recognize paraphrases effectively and provide the same answers to paraphrase questions. So our approach to this problem is that we explore whether recent state-of-the-art models are capable of recognizing two paraphrase questions using unsupervised learning. And we need data sets to test the QA model's ability to recognize paraphrase questions and analyze their performance. Therefore, we use two datasets based on Squad to conduct two separate experiments on the QA models. And we create and visualize useful sentence embeddings of paraphrase question pairs by the language models. We describe qualitative investigations on these models and how they present paraphrase questions in contiguous space. So some results. The first one demonstrates that the paraphrase dataset confuses the QA models and leads to a decrease in their performance. The second result is that visualizing the sentence embeddings of paraphrase question pairs by the language models suggests that all models, except BERT, struggle to recognize paraphrase questions effectively. So a quick outline. I will first discuss the methodology, and there we'll discuss the models and the two datasets. Then I will discuss the results and finally the conclusions with some limitations. So let's start with the models. We use pre-trained QA models that are based on the transformer architecture to conduct the two experiments. And the first model we use is Google's BERT. The second model we use is OpenAI's GPT-2. And GPT-2 is also a transformer model and has a similar architecture to BERT. ExcelNet, the third model, has an alternative technique that brings back the merits of autoregression while still incorporating the context on both sides. The network structure of the transformer models compute no independent sentence embeddings. Therefore, we modify and adapt transformer networks to obtain sentence embeddings that are semantically meaningful and used for our visualizations. And we use the mean pooling technique to retrieve the fixed size sentence embeddings. We also explore the traditional word-based model GloVe and compare its sentence embeddings to the state-of-the-art transformer models. So the first dataset is called DevPara. And DevPara is publicly available and we use it to evaluate the model's oversensitivity to paraphrase questions. DevPara is created from Squad development questions and consists of newly generated paraphrases. So this is how the Squad development set looks like. On the left you can see a Wikipedia extract, like a paragraph, and on the right you can see the questions with their answers. So the second dataset we use is called Parasquad. And we created this new paraphrase elevation set to test the QA model's ability in recognizing the semantics of a question in an unsupervised manner. Parasquad is a subset of the Squad development set, whereas DevPara is much larger and consists of newly added paraphrases. The question pairs used in Parasquad are manually annotated and picked from the Squad development set. And to be more specific, we consider questions as paraphrases if they yield the same answer and have the same intention. And the main criteria for well-written paraphrases are fluency and lexical dissimilarity in our paper. Moreover, word substitution is sufficient to count as a paraphrase, in our case. Using Parasquad for visualization has a significant advantage compared to using DevPara. Namely, the data distribution of DevPara changes after the addition of new sentences. On the contrary, the data distribution of Parasquad remains the same because we do not add new sentences. We only annotate existing paraphrases in the Squad development set. So, We present a proof of concept visualization of the model's capability to represent semantically similar sentences closely in vector space. And we map all the paraphrased questions from Parasquad to a sentence embedding space for every pre-trained model. So now we're going to discuss the results. And firstly, we're going to look at the performance of the QA models on DevPara. And secondly, we're going to look at the visualization of the sentence embeddings of Parasquad. So the QA model's performance on DevPara is presented in Table 1. And although the original set of DevPara is semantically similar to the paraphrase set, we can see a drop in performance of all the three models in the table. Especially GPT-2 and ExcelNet are suffering a significant drop in performance. And the drop in performance is unexpected, since the meaning of the questions did not change between the original set and the paraphrase set of DevPara. One possible explanation is that the model is exploiting surface details in the original set that are not reproduced by the protocol used to create DevPara. And if this is true, then this demonstrates a lack of robustness in the models. So next we're going to look at the visualizations, and we'll start with GPT-2. But first, each point in the space represents a question, and the 12 colors represent different categories. The line in figure 2 illustrates the distance between the paraphrased questions pairs. If two sample points are far from each other in the plot, it doesn't necessarily imply that they are far from each other in the embedding space. However, the number of long distances between paraphrased question pairs coming from different clusters can reveal information on the robustness of the models to recognize paraphrased question pairs and their semantics. So as we can see, GPT-2 has trouble clustering different categories, and after manually analyzing the sentences in the different clusters, it seems that GPT-2 offers special attention to the first token in a sentence. And it seems that GPT-2 organizes questions by their structure instead of their semantics. So the next model is BERT, and figure 3 shows that BERT creates clear and distinct clusters for every category. We only observe a few errors, and most paraphrased questions are within the same cluster and close to each other, as we can see in figure 4. Therefore, it seems that BERT can capture similar semantic sentences quite effective. Next model is ExcelNet, and ExcelNet forms one large cluster with smaller clusters within. However, these clusters are not that clear when compared to BERT, and the different categories are all spread out, and no apparent clusters are formed. Lastly, we have GloVe, and if we look at figure 7, it suggests that GloVe clusters the different categories more effectively than GPT-2 and ExcelNet, despite using static embeddings. And this finding is interesting, since contextualized embeddings are thought to be superior compared to traditional static embeddings. So let's talk about conclusions. And the results demonstrate that all three QA models drop in performance when exposed to more unseen paraphrased questions. The drop in performance could be explained by exposing the models to new paraphrased questions that deviate from the original squad questions. The experiments underline the importance of improving QA models' robustness to question paraphrasing to generalize effectively. And next, the findings of the visualizations reveal that BERT creates the most promising and informative sentence embeddings and seems to capture semantic information effectively. The other models, however, seem to fail in recognizing paraphrased question pairs effectively and therefore lack robustness. Some limitations. One limitation of the performed experiments is the small size of Parasquad. However, increasing the size of Parasquad would lead to more reliable results, but we would lose the advantage of keeping the data distribution intact. And another downside is the simplicity of Parasquad. The paraphrases used are relatively simple and basic. Therefore, models achieving excellent results on the set does not guarantee the robustness to question paraphrases. And using visualization as a primary evaluation method has its risk. And a common pitfall includes pareidolia, and that is to see structures and patterns that we would like to see. Lastly, with the perform method, it is hard to distinguish whether BERT recognizes the actual semantics of the questions or merely the Wikipedia extracts. So further research is needed to investigate this distinction. Thank you very much for listening, and if you have any other questions, I'm very happy to answer them during the Q&A, or if you would like to send us an email, I provided the emails down below. Thank you very much.